Okay, so let's consider independent events. These are what we've been looking at in class. And what it means is the fact that if you do two things, like pick two marbles from a bag, the likelihood of picking a second one is not affected by what you draw on the first one. And the reason for that is because you put it back in the bag, and the key word here is replaced. So let's remind ourselves of what that looks like. Here's a paper bag. We've got 6 blues, 5 reds, so it's 11 in total. We can draw ourselves a probability tree. Our first event of picking a marble, red or blue, we know that it's either going to be 5 out of 11 for red or 6 out of 11 for blue. That's pretty straightforward. Okay, there's those probabilities. We take our marble out, it's a blue one, but it doesn't really matter because before the second event we put it back. So the probabilities are still the same for our second event of getting a red or a blue. It's still going to be 6 out of 11 chances of getting blue or 5 out of 11 chances of getting red. And we can draw those onto our probability tree as we have done. Then we can multiply along the branches to figure out the probability of getting either a red and a red, or a blue and a blue, or blue and a red, or a red and a blue. Multiplying them together, we get the probabilities, and then what our question is asking us is what is the probability of picking different colour marbles one after the other if the first one is replaced. So different colour would be red and blue, but it could also be blue and red. Therefore we add those two together, and the probability of getting a different colour marbles when you replace the marble is 60 out of 121. Okay, so let's look at dependent events, and the definition is two events are dependent if the outcome of the first affects the outcome of the second so that the probability is changed. It may sound a bit complicated, but if we look at it, I think it's pretty straightforward. So this time, let's do the same exercise, but what we're going to do is we're not going to replace the marble. So we're still trying to find the probability of picking different colour marbles. We've got 6 blue ones and 5 red ones. Here's our bag. There's our 6 blues. There's our 5 reds. Here's our probability tree. So far, so good. Event 1, we know it's going to be the same. We know we've got a 6 out of 11 chance of picking a blue and a 5 out of 11 chance of picking a red. Okay, so we take a marble out. It's a blue one. Okay, but this time we're going to leave it out. We're not going to replace it. So for our event 2, okay, now what's the probability of us picking a red or a blue? Well, what we've got to consider is how many marbles are left in the bag. There's only 10 left in the bag, and there's 5 red ones and there's 5 blue ones. So if we look at red first, the probability of the second event of picking a red marble after picking the blue one is 5 out of 10. And then we do exactly the same as we did before. So we look at 6 out of 11 was our first choice, times 5 out of 10 was our second. Gives us 30 out of over 110. So again, the chance of it being blue in the second event, remember we've taken 1 blue out already. So if you actually look at the bag, you can count them 1, 2, 3, 4, 5 out of 10 marbles. So it's 5 out of 10 as well. And calculate those along, and we have a similar probability. Okay, now what we have to consider now is the other side of the probability tree, and that would have been if we picked a red one first. So to consider that, let's start again from the beginning, and we pick a red one first this time. Out it goes, and then we have to look at what's left in the bag for the second event if we'd picked a red marble first. So we can see that there are 4 red left and there are 6 blue left, and in total what's left in the bag is 10 marbles. So again, it's going to be out of 10. If we look first at picking a red for the second one after picking a red for the first one, that probability is 4 out of 10. We times them together and as we've done before, we calculate our probability. And so that means that the one that's left is what is the chance of picking a blue on the second event, and that's 1, 2, 3, 4, 5, 6 out of 10. There we go. And again, we multiply it along the branches, giving us our probability of picking a red then a blue. And then we have to go back and look at our question. What does it say? It says, what is the probability of picking different colour marbles one after the other if the first one is not replaced after being picked? So different colour, that's red and blue and red. And this time that's given us, we add those together, so we get 60 over 110. Which is different to 60 over 121, which is what we got when we were replacing the marble when we did it the first time. So hopefully you can apply that to the homework question and look at it again and have another go at working out the probability without replacing the marble.